So this is the second part of 2.5. We're talking still about the fundamental theorem of algebra. Today we're going to go backwards. Yesterday we had, our big gross polynomials, and we factored them. We did whatever we needed to do to find our zeros. Today they're going to give us the zeros. We're going to work backwards. Something that you really need to pay attention to, and a lot of you yesterday were totally fine with this, is, why is my handwriting so bad? Okay. When we talk about complex zeros, guys, right, you always have to think about and account for conjugates. We've talked about what conjugates are. If it's in the form of a plus bi, you change the sign in the middle. Meaning, this was a question yesterday on WebAssign. If they give you a complex zero of 2i, you automatically assume and write down that another zero is negative 2i. Okay, that's very important for you guys to remember because our imaginary solutions are always plus minus because we're taking square roots of negative numbers. So, in a problem like this, we're just going to do a bunch of examples right now. In a problem like this, it says find the fourth degree polynomial Find the fourth degree polynomial for the function with the coefficients -1, -1, 3i. Okay, these are the zeros. If I have a fourth degree polynomial, the highest exponent in my function should be what?
4.
X to the fourth. So look, they gave me 1, 2, 3 zeros, but they actually gave me 4 zeros. They gave me x equals -1, x equals -1, x equals 3i, and then I also have to account for the conjugate, so I'd write down x equals what? -3i. All right, you always have to account for the conjugate, and we'll do this more and more. But what we're doing, guys, is we are taking the zeros and we're working backwards to the big long polynomial function. So like we did yesterday with our linear factorization, all right, we're going to write out what our binomials would look like. If I move -1 to this side, would you agree with me that it becomes +1? Yes or no?
Yes.
Yes. If I move -1 over here, would you guys agree that this binomial would be x plus 1? This 3i over here would give me x minus 3i, and this 3 over here would give me x plus 3i. All right, we're going to set this equal to 0. Everybody with me?
Mm-hmm.
Now this just becomes a big foiling problem. You can't FOIL 4 binomials together at one time, so I'm going to split them up. I'm going to FOIL my reals, and then I'm going to come over here and I'm going to FOIL the imaginaries, and then I'm going to put them together. So, with me, guys, I'm going to do this one pretty quickly. X times x is x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. So I'm left with the trinomial x squared plus 2x plus 1. Everybody agree?
Yes.
Okay, so now we're going to do the same thing with x minus 3 and x plus 3. So x times x is x squared. X times 3i is plus 3xi. Negative 3i and x is negative 3xi. If you wrote ix, it doesn't matter. And then negative 3i, positive 3i is 9i squared. As soon as I see that I squared, what do? Cross it off and change the sign. What do you notice happens here with my positive and negative 3xi?
Cancel.
They cancel out. So I'm left with x squared plus 9. And then what do you guys think I do now?
FOIL that.
We're going to FOIL that. Last period, someone asked me, can I write the x squared plus 9 in front? Absolutely. If you wanted to rewrite this as x squared plus 9 times x squared plus 2x plus 1, you're perfectly fine. What do you guys notice happened to my eyes? Do I have any?
They canceled out.
Yeah, they canceled out. We don't have any polynomials. You guys have never seen a polynomial that I gave you that had an I inside the polynomial that you had to factor. So every time you guys find the resulting polynomial given the zeros, whatever, you should not have any i's. They should all cancel out. So if they don't, you did something wrong. But now we're going to just distribute. So x squared times x squared is x to the fourth. X squared times 2x is plus 2x to the third. X squared times 1 is x squared. 9 times x squared is plus 9x squared. 9 times 2x is plus 18x. And 9 times 1 is 9. Questions? Now what do you think we do? Combine.
Order it.
Let's combine like terms.
Like terms.
So x to the fourth plus 2x cubed. 1x squared and 9x squared gives me 10x squareds plus 18x plus 9. So you can either write f of x equals, or you can set equal to 0. But you're working backwards. You're given the zeros, and you're going to work backwards to what the polynomial is. It's not anything that's like, oh my gosh, this is so abstract and I can't wrap my head around it. It's just the fact that this was easier because we had all plus signs. But when you have a minus sign, or if you miss that x squared times x squared is x to the fourth, any little tiny mistake that you make, it's really hard for us to give you guys extra or partial credit, because it really transforms the entire problem. So you guys have to be super careful as you're going through these. That's why I want you to do 100 of them. That's why we're taking time. We're going to spend time on working these out, and then we're also going to spend time on reviewing, because you need to make sure that you're through this at a relatively decent speed, but you get it done. All right, I'm going to skip number 1 because those are all reals. We'll just talk about it for a second. What would my 3 parentheses look like? X plus 5, right? You can say x plus 0 and x minus 2.
And x minus 2.
So I would FOIL those two together, and then I would just FOIL in an x as you go through here. But let's look at these two, all right? I have 2 zeros that they gave me. Are both of them real? Yep. I don't have to worry about conjugates or anything like that. So my first binomial is going to be x plus 5, because when I move this over, it becomes positive, right? And this root 3, when I move it over, it becomes x minus root 3. So when we FOIL this, guys, x times x is x squared. X times negative root 3 is just minus x root 3. 5 times x is plus 5x. And then 5 times negative root 3 is minus 5 root 3. Can I combine any like terms or anything like that? No, right? This has a root 3 and this has a root 3, but can you say x minus 5 is anything other than x minus 5? No. So there's your answer. Does that make sense? You guys okay? I hate not being able to see you. Okay. All right. They gave me 2 zeros here, but how many do I really have?
3.
Why?
2y, negative 2y.
Perfect. I have an imaginary. That means I have to account for that conjugate. So I have negative 2i and positive 2i. So I'm going to have 3 binomials. If I move negative x to the other side, negative 1 to the other side of the equal sign, I have x plus 1. If I move positive I to the other side of the equal sign, I have x minus 2i. And if I have negative I and 2i and I move it to the other side, I have x plus 2i. Everybody with me? If I'm going too fast or something, tell me, please. Now, it's your choice how you guys want to do this. If it were up to me, I would leave x plus 1 outside here, and I would FOIL the 2 imaginaries. X times x is x squared. X times 2i is plus 2xi. Negative 2i times x is negative 2xi. Negative 2i and a positive 2i is negative 4i squared. As soon as I see that I squared, I cross it off, change the sign. What happens with my negative and positive 2xi's?
They cancel.
They
They
cancel.
cancel, good. So you're left with x plus 1 times x squared plus 4. Now, you can kind of give yourself a little check at this point, because if I were to ask you right from this point, right here, to solve, you would set each parenthesis equal to 0, right? So x plus 1 equals 0, I would get x equals negative 1. X squared plus 4 equals 0, I'd move the 4 to the other side, so I'd get x squared equals negative 4. When I take the square root, that's where I get my plus and minus 2i. So at this point, you can kind of look and say, okay, I'm on the right track. All my i's canceled out. If I can visually kind of give myself a little checkpoint and say, okay, I think I'm on the right track, because if I solve these two, I'd get those zeros. So you're good to go. So now I'm going to FOIL again. So I have x cubed. X times 4 is plus 4x. 1 times x squared is plus x squared. And 4 times 1 is 4. And then we just rewrite in standard form. So x cubed plus x squared plus 4x plus 4. And if you wanted to check yourself at this point, what could you do? What could you do at this point to check yourself?
Do the either try and group it
Mm-hmm.
or
You just try and factor it. You can group it. If that doesn't work, you can do synthetic division, whatever. But you should be able to factor your resulting polynomial and get the zeros that you started off with. Again, this isn't crazy hard. It's just kind of like, bleh, it's a lot. It's a lot.
Miss Meta,
Uh-huh.
if you for the last one for number 2, because there's like a square root or no the one because there's like x and x square root 3 and 5x, it doesn't matter which one you put first, right?
No. I'd put the variable first just because, but not really, no.
Okay.
All right, in this example, let's cross off 3i, just because this problem gets really long. And for the sake of time, I want to make sure I get through everything. So we're just going to go with these are the two x's that they gave me. But did they really give me 2? How many did they really give me? I have a real one right there. I have 2 plus I. That's imaginary, so I have to account for what?
2 minus I?
Yep, the conjugate of 2 minus I. Now, if I'm going to write this out like this right now. You guys don't have to, but just so you can see this, I'm going to write this out like this now. These are the 3 zeros that they gave us. So when I take this -4 and I move it over here, would you guys agree with me? This becomes x plus 4, right?
Yes.
Okay, guys, this positive 2 plus I is together. Look at that lead term. So when I bring positive 2 over here, it becomes x minus 2 plus I. When I bring this 2 minus I, this is a positive 2. So when I bring it over, it becomes x minus 2 minus I. You don't change that sign in the middle. Okay, that's a very big step. Some of you are going to mess that up. You're going to say x minus 2 and x plus 2. That's not what it is. When I move that over, that 2 becomes negative each time. It's positive, so when you move it over, it becomes negative. You've got to be careful with that. Now, I'm going to show you the long way to do this, and then I'm going to show you a shortcut. If you do not like the shortcut or you don't follow along with what I did with the shortcut, that is okay. You don't have to do it that way. But once you get the hang of the shortcut, your life is so much easier. So I'm going to leave this x plus 4 just hanging out here by itself. We're going to worry about the 2 imaginary ones. What is right in front of each of these parentheses that I have to worry about before I FOIL?
A negative.
A negative. So I'm going to distribute this negative. So this is really x minus 2 minus I. I'm going to distribute this negative, and this becomes x minus 2 plus I. Now, some of you are going to say, does that happen every time? Yes. Some of you are going to say, if I see that, can I just write it that way? Yes. But I just wanted you to see the math behind it. At both of the 2's at the original 0 are positive. It's a positive 2 plus I, and it's a positive 2 minus I. So when you move it over, that's why they both have a negative sign with them. Now, we're going to do this the long way, and then I'm going to come back up to this step and show you the shortcut. So here's x plus 4. It's just going to hang out there. This is just a trinomial times a trinomial. I'm going to do it in 3 different colors so you can see. X times x, x squared. X times negative 2, negative 2x. And x times I is positive xi. Any questions for that one? We're good? Okay, now I'm going to take negative 2. So negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. And then negative 2 times I is negative 2I. Y'all with me? Okay. Now I'm going to take the negative I. So negative I times x is negative ix, or xi. Then I'm going to say negative I times negative 2 gives me positive 2I. And then I have negative I and a positive I gives me negative I squared. Oh, as soon as I see that negative I squared, I'm going to cross it off and put a plus 1. Ooh, we're getting lots of emails right now. All right, so this is a big mess, but all it is just, all we did was just multiply a trinomial a trinomial. So keep x plus 4, he's just hanging out. Let's combine like terms. So I have x squared. I have a negative 2x and a negative 2x. Gives me negative 4x. Agreed? All right, I have a positive xi and a negative xi or ix. Doesn't matter. The order doesn't matter. It's the same. They're both the same, first power, whatever. So what happens with a positive and a negative xi?
They cancel out.
They cancel out. And then I have a plus 4. Anything else with plus 4? Plus 1. So 4 plus 1 is?
5.
Oh, thank you. That was a little scary. And then what happens with my negative 2i and my positive 2i?
They cancel.
They cancel out. Which is what should happen. Because I remember when we first started talking about this, I said all of your i's should cancel out. So when you get your resulting polynomial, you're good to go. So now all we do is just distribute again. So x times x squared is x cubed. X times negative 4x, negative 4x squared. X times 5 plus 5x. 4 times x squared plus 4x squared. 4 times negative 4x is negative 16x. And 4 times 5 is 20. And the last thing we're going to do is combine like terms. So I have an x cubed. I have a negative 4x squared and a positive 4x squared. What does that give me?
0.
0. I have a positive 5x and a negative 16x. So that's what? Negative 11x plus 20. There's my polynomial. How do we feel? I know some of you are sitting here like this. That's okay. We're going to practice. Does anybody want to see the shortcut?
Yes, please.
You guys all love shortcuts. Who doesn't love a shortcut? All right, so look, I'm going to go right here from this step. Okay, I'm going to rewrite this step over here. We had x, let me get my signs right, plus 4. And then when we distributed the negative 1, we had x minus 2 minus I. And then we had x minus 2 plus I. Okay, remember that step? All right,
Yeah.
Little side work here. If I asked you to FOIL that without doing anything, what is my answer when I FOIL those two together?
The 3 one,
This one right here.
x squared minus 9.
Yep, that's the difference of perfect squares, right?
Wait, where did you get that from?
I just made it up because I want to show you something real quick.
Oh, okay.
Keep that concept in your mind. Look at this. What do you notice about this and this?
It's the same thing.
They're the same, right? I have two of them. What do you notice about that letter and that letter? Just the letter.
They're the same.
They're the same. I have how many of them? Two of them. Are they the difference of perfect squares? Yes, they are. Put a minus sign in the middle. This will work every single time. If I work this out, I have x minus 2 times x minus 2 minus I squared. Well, what's I squared?
1.
Negative 1. And then I change the sign in front, so I get plus 1, right? So if I FOIL this, x times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. Negative 2 and negative 2 is positive 4. So I have x squared minus 4x plus 5. Is that the same thing we got right there? Same thing.
So for the first part, you kept the x plus 4?
Where?
I don't know.
I foiled these two together. X minus 2, x minus 2. I just foiled them.
But why did you circle the x minus 2 again? Because they're the same.
They're the same. I was just showing you that they're the same, and then they're the same here. So all you do is square that first binomial, square the second term, put a minus sign in the middle every single time.
What about the x plus 4?
Oh, we'll go back into that. I mean, then you would just go, okay, x plus 4 times x squared minus 4x plus 5, which is what we did here, right?
Yeah. But do the i's have to have 1 plus and 1 minus?
Yeah,
Or-
but it will all the time.
Okay.
Because you're always going to do the conjugate. Now, if you not you, but if people mess up and don't do plus the second term, if they don't switch the sign or whatever to do the conjugate, then no, this won't work. But if you do it the right way, it will work. We'll do another one in 1 second. Let's look at this. You guys are going to get a question, and you're going to be so excited about it because we get to do long division. All right, they're going to say find all the zeros, all of the zeros. This is not a synthetic division because they're going to give us one of the zeros. So in this problem, x to the 4th, how many zeros should I have?
You should have 4.
4.
I should have 4. So over here, I'm going to remind myself I have x equals, x equals, x equals, x equals. Well, one of the zeros is 1 plus 3i. So I know the other one, or another one, could be what? Or is, not could be.
1 minus 3.
1 minus 3i. You always have to account for the conjugates. So what they're going to do in a situation like this is they're going to give you the imaginary ones, and you're going to work backwards to find the real ones. 2 steps you have to do. The first step is you are going to multiply the 2 zeros that they gave you together. So I have x 1 plus 3i, and I have x equals 1 minus 3i. So think about this, okay? Just what we just did. This is one thing together that I'm going to move to the other side. So this parenthesis becomes x minus 1 plus 3i. You guys with me?
Yep.
Okay. This is one thing together. That one is positive. So when I bring it over here, this becomes x minus 1 plus, sorry. Where's my 1 minus 3i. Now, once you get to that part, the rest of this is easy. We're going to distribute that negative sign. So this becomes minus 1 minus 3i. This becomes x minus 1, what? Plus 3i. Now, you can FOIL this out. You can multiply and distribute trinomial times a trinomial, but let's try the shortcut. Are those two exactly the same?
Yes.
Yes, so I'm just going to write x minus 1 quantity squared. Is this term the same as this term without the signs?
Yes.
Yes.
So I have 3i quantity squared. Since this is the difference of perfect squares, you put that minus sign in the middle. And now we just use our algebra skills and we say, okay, well, this becomes x minus 1 times x minus 1 minus, if I distribute this, this becomes 9i squared. As soon as I see I squared, what happens?
Cross it out and make it the opposite sign.
Yep, cross it out, make this a plus. So now let's just FOIL this real quick. X times x is x squared. X times 1, did I forget to put the 1 there? Yep. X times 1 is negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is plus 1. And then I have plus 9. So when you combine like terms, x squared minus 2x plus 10. And you guys are like, woo, good thing we're done. We are not done. That is the first half of the problem. The second part, and I'll finish the examples that I have, I'll finish them on the video after school, so you guys have all of this, because I'm not going to get through it all. But the second part that we have to do is we say, okay, great, all right? We figured out what these two zeros are combined. So now you're going to take this x.
Wait, Miss Natalie?
Yep.
Sorry, I have a question.
You're fine, you're fine.
When you do the 3i squared
Mm-hmm.
and you distribute the squared, what do you do with the minus again? Do you distribute the minus?
No. You don't do anything with the minus yet, because when you distribute the squared, you get 9i squared, right? And 9i squared, there's a minus in front of it. Well, when you see i squared, you cross it off and you change the sign in the front. That's where we got that plus 9.
Okay, so you change it in front of the whole thing. Oh, wait. Okay.
In front of
I
that
gotcha.
term, yeah.
Thank you.
No problem. All right, so now, guys, we're going to take x squared minus 2x plus 10, and we're going to divide it into our original polynomial. X to the fourth minus 3x cubed. Do you guys see why signs are so very important? This is an extremely long process, so if you miss a sign up at the beginning, there's no way you can get the rest of this problem right. The good thing about this, though, is the same thing will happen every time. If you're doing the process correctly, when I divide x to the fourth minus 3x divided by x squared minus 2x plus 10, you should get no remainder. You're finding the real zeros, and it'll work out every time if you did it right. So it's a nice feeling at the end. But long division, we know how to do this. You guys, this class especially, did really well on this question. So x squared times what gives me x to the fourth?
X squared.
Okay, so I'm going to put my x squared above my x squared to keep everything in order. Get your subtraction ready, and then multiply. X squared times x squared is x to the fourth. X squared times negative 2x is negative 2x cubed. X squared times 10 is plus 10x squared. Before we can subtract, we have to change all the signs. So change. So 6x squared minus 10x squared is negative 4x squared. Negative 3x cubed plus 2x cubed is negative x cubed. My x to the fourth is cancel out. Fourths, not fourths. And then I bring down the 2x. And then we just start the process all over again. First term into first term. Well, x squared times what gives me negative x cubed?
Negative x.
Yes, ma'am. So I'm going to put my negative x right here, and then I'm going to multiply. Negative x times x squared is negative x cubed. Okay, so we have negative x times negative 2x is plus, right, 2x squared. Negative x times 10, negative 10x. Better? Bella, better?
Yeah.
Okay, so now let's distribute. Change. So 2 and 10 gives me 12x. Negative 4 and negative 2 gives me negative 6x squared. And then I bring down my minus 60. And we're going to do it one more time. I know this is a lot. I know this is a lot. So I have x squared into negative 6x squared. So x squared times what gives me negative 6x squared?
Negative 6.
Negative 6. Get your subtraction ready. Negative 6 times x squared is negative 6x squared. Negative 6 times negative 2 plus 12x, right? Negative 6 times 10 is negative 60. Before we can subtract, we have to change. What's a negative 60 and a positive 60?
0.
0. What's negative 12 and positive 12x? 0. What's negative 6x squared, positive 6x squared? 0. So we are almost done. Not there yet, but so close. Because I take this, and what can I do with this?
Solve for the last two zeros.
Yep, let's solve for the last two zeros. What happens with negative 6? When I multiply, I get negative 6, but I add and get negative 1. X minus 3, x plus 2. Agreed?
Agreed.
Okay, so x equals 3 and x equals negative 2. So your answers, ladies and gents, for this wonderful problem are x equals 3, negative 2, and 1 plus 3i, 1 minus 3i. Now again, this problem is not anything like, we're going to get to some stuff in the next couple days that we talk about domain and range and stuff that's very abstract. This isn't abstract. This is your basic algebra, but there's so many things that go into it. There's so many ways you can make mistakes. There's so many little things that you guys have to pay attention to that it can be overwhelming. If you only do 1 or 2 of these problems between now and the test, you're never going to get it right. But I promise you, if you do all of the WebAssign stuff, tomorrow I'll work through them so we can look and troubleshoot. If you do all of the practice problems that we give you, this will become second nature, and you'll be like, oh, this is the same thing every time. It's just long. It's just long, and I know that. The next, I have 2 more examples that I wanted to do, but I don't have enough time. Let me try and get this one going. Let's see if we can do this one. We might be able to get this one done. All right, find all the zeros. How many zeros am I looking for in this problem?
3.
3, okay. So they already gave me 3 plus 2i, so that means they already gave me 3 minus 2i, right? This is a shorter problem. So I'm only looking for 1 more. This is not going to be bad. So the first thing I'm going to do is I'm going to set up my x equals 3 minus 2i and my x equals 3 plus 2i. So when I do my 2 parentheses and I bring this over here, do you guys agree this is x minus 3 minus 2i, and this is going to be x minus 3 plus 2i. Everybody with me?
Yes.
Okay, distribute that negative. So we have x minus 3 plus 2i, x minus 3 minus 2i. Are we good? We're okay?
For now.
Huh. Okay, so look, x minus 3, I have 2 of them, so I can just write that as x minus 3 quantity squared. I have a 2i here and a 2i here, so I can write that as 2i quantity squared. And then what's that sign that goes in the middle? For my difference of perfect squares, a minus sign, okay? So I'm going to work this out here. So I have x minus 3 times x minus 3 minus, when I distribute this, I get what? What's 2i squared, quantity squared?
-2.
Minus 4i squared.
Okay, minus 4i squared, because that 2 goes to the 2 and to the I.
Right.
Then we cross off and change the sign. So now FOIL this real quick. X times x is x squared. X times negative 3 is negative 3x. Negative 3x, positive 9, and then I have plus 4. So I have x squared minus 6x plus 13. Now what do I do with that?
By the given.
Mm-hmm. Not by the given. Oh, you're saying given here, the given polynomial. Yeah. So I'm going to say, okay, my given polynomial is x cubed minus 11x squared plus 43x minus 65. And I have x squared minus 6x plus 13. So let's do our long division. First term into first term. X squared times what gives me x cubed?
X.
X. So I'm going to put it right above my x column. Get your subtraction ready. X times x squared, x cubed. X times negative 6x, negative 6x squared. X times 13 plus 13x. Yes? Change, 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 change. What's 43 minus 13?
30.
30x, right?
X,
Negative 11 plus 6 gives me negative 5x squared. My x cubes cancel out, bring down that minus 65, and we're going to do it all over again. First term into first term. So I have x squared times what gives me negative 5x squared.
-5.
So minus 5. Now let's multiply. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 6 is positive 30x. Negative 5 times positive 13 is negative 65. Before I can subtract, I need to change. What's negative 65 and positive 65? 0.
0.
What's 30x minus 30x?
0.
What's negative 5x squared, positive 5x squared?
0.
So x minus 5 is what I'm left over with. So if I'm going to find the 0 here, x minus 5 equals 0. So x equals how much?
5.
There you go. So your 3 zeros for this problem are x equals 3 plus 2i, x equals 3 minus 2i, and x equals 5. Okay, so let's look at the next one. They gave me the 0, which is x equals negative 2 minus 5i. That means I also have a 0 at x equals negative 2 plus 5i. We always have to account for the conjugate. All right, I'm starting off with x to the third. That means I have to have 3 zeros, so I'm going to find one more, and it's going to be real. So the first step we're going to take, guys, is we're going to take our imaginary complex solutions, negative 2 minus 5i, and x equals negative 2 plus 5i. And remember, this is a negative 2, so when I bring it to the other side, it's going to become positive. So we'll have x plus 2 minus 5i, and then we have x plus 2 plus 5i. I don't have to worry about distributing a negative or anything, so that's why I didn't put it in parentheses. But now I can look and I say, oh, I see. I have an x plus 2 here and an x plus 2 here. That gives me x plus 2 quantity squared. I have a 5i and a 5i, so that gives me 5i quantity squared with a minus sign in the middle because it's difference of perfect squares. So I have x plus 2 times x plus 2 minus, when I distribute this, I get 25i squared. As soon as I see that I squared, I cross it off and put a plus. So if we FOIL this, x times x is x squared, x times 2 is 2x, plus 2x, plus 4, plus 25. So we have x squared plus 4x plus 29. So now I'm going to say, I'm going to divide x squared plus 4x plus 29 into my original polynomial, which is x cubed plus 11x squared plus 57x plus 203. So guys, first term into first term, x squared times what gives me x cubed? You guys are going to tell me x, so I'm going to put an x right here above my 57. Get your subtraction ready before you multiply. So we have x times x squared is x cubed. X times 4x is plus 4x squared, and x times 29 is 29x. Now, before we can multiply, we have to subtract, change. So 57 minus 29x is 28x. 11 minus 4 is 7x squared, and my x cubes cancel out, and now I'm going to bring down my plus 203. So now again, first term into first term. So x times what gives me 7x squared? You guys are going to tell me 7, positive 7. So get your subtraction ready before you multiply. 7 times x squared is 7x squared. 7 times 4 is 28x. And what do you think 7 times 29 is? Yep, 203. Now before we can do any subtraction, we have to distribute that negative. So plus, minus, change. 203 minus 203, nothing. 28 minus 28, nothing. 7 minus 7, nothing. So guys, we're left with x plus 7. We set that equal to 0, and I get my final 0 of x equals negative 7. So your three answers would be negative 2 plus 5i, negative 2 minus 5i, and x equals negative 7. And there you have it.